Are you struggling to understand continuity or just haven't learned it yet? Well, look no further. When we talk about continuity, we use a three-part definition for continuity at a point. Here we're using the point x equals c. The way that I remember this, we have 3 points, but we really only need to know 3 things. What do I mean? We have 1, f of c exists. 2, the limit as x goes to c of f of x exists. We've already seen exists twice. And the last point, and really the most important point, is that f of c equals the limit as x goes to c of f of x. So we see the limit twice in the second part and the third part. We see f of c twice in the first part and the third part, and exists twice. However, like I said, the third part is the most important part. Let's take a look at a function. F of c, does it exist for this graph? Here's c, here's f of x. F of c, yeah, it looks like it's at 3, so that's fine. 2, does the limit as x goes to c of f of x exist? Yeah, as we come from the left and the right, we go to the same point. We go to 3. Are these equal? Yes. So, is our function continuous? Yes. Another way of thinking about continuity is if we put down our pencil to draw our graph, like so, and we can draw the entire graph without picking up our pencil, then we have a continuous function. F of c, does it exist? Yeah, we have a point at c, comma 3, negative 3. The limit as x goes to c exists. Well, if we look on the left side, on the right side, they're going to the same point, they're going to 2, so we don't violate either the first or second part. However, these two things are different, so we violate the third part of the definition. Here we have another function. We're looking as x goes to 0. So, does f of 0 exist? Yeah, it's up here at 5. So we would be fine there. Does the limit exist? As we come to 0 from the left, we're going towards negative 4, and as we're coming from the right, we're going to 5. So this would violate the second part of the definition. If we violate the second part, we surely are going to violate the third part. This function is not continuous at the point x equals 0. Our fourth function, if we plug in, here I put a, I've been talking about c, but here we have a. F of a, does it exist? Well, it's close, but we have an open circle at 3 and at 1, so we don't have a value at that place. We'd violate the first part of the definition. We could keep checking. On the left side, we're going to 3. On the right side, we're going to 1. Well, we'd also violate the second part, and so if we violate the first and the second, surely we're going to violate the third part of the definition. This function is not continuous.